Hello everybody. Today we are going to discuss an important chapter related to plus 2 physics, namely the semiconductor electronics, materials, devices and simple circuits. Now, electronics is widely used in everywhere, every branch and in daily life. Hence it is the most important chapter. Here we are going to discuss some questions related to this important chapter. Now the first question is, at absolute zero, that means at the lowest possible temperature, silicon acts as you know, germanium and silicon are semiconductors. These are used for doping and used for the construction of semiconductor devices. Silicon is actually a semiconductor at ordinary temperature, but at absolute zero of temperature, electrons cannot move. Hence it will act like an insulator. At actual temperature, it will act like a semiconductor. But at absolute zero of temperature, silicon will act as insulator. Correct answer is option A. Now it is question number 2. A p-type semiconductor is whether it has positive, negative, neutral or anything. P-type semiconductor is obtained by adding trivalent impurity to a semiconductor. Hence, there is a deficiency of an electron and this is called hole. But as a whole, there is no removal or addition of electrons to it. Hence, total number of electrons and holes in the material remains constant. Total charge remains unchanged. Hence, a p-type material as a whole is to be electrically neutral, while the conductivity is only because of positive charged holes. The reason for conductivity is positive charged holes, but the material as a whole is electrically neutral. Hence, the p-type material is electrically neutral. The correct answer is option C. Now it is question number 3. A figure is given, forward biased diode. Which one is forward biased? For a diode to become forward biased, P side is to be positive or P side is to be more positive when compared to N side. Here it is -4 and -3. This will result in -1 volt and 0. Hence P is negative, not forward bias. Here it is 3 volt and 5 volt. Here is 2 volts extra. Hence it is not forward bias. Here it is -2 plus 2. Net voltage is 0. Not in forward bias. Here it is 0, while it is -2. Here it is more positive compared to here. Hence, option D, this diode is in forward bias. Correct answer is option D. Now, question 4. In a half-wave rectifier, operating from 50 Hz means frequency. The fundamental frequency is the ripple. Ripple means the output of rectifier contains some AC components and it is called ripples. Rectifier is used to convert AC to DC. For a half-wave rectifier, output frequency is equal to input frequency. For a half-wave rectifier, the input may be like this is the input AC and the output will be like this. Frequency related to this term for a cycle. Here output frequency equals input frequency. And hence, if input frequency is 50 Hz, the output frequency is also to be 50 Hz. Whereas, if it is a full wave rectifier, then it will be like this. The output frequency is equal to 2 into input frequency. If so, it is to be 100 Hz. Here it is half wave rectifier, so that output frequency and input frequency are same. Hence, the answer is option B, it is 50 Hz. Now, it is the last question related to this chapter. Question number 5. Assuming that the diode is ideal, current through the diode has two points, namely P and N type when joined to form a diode with a junction. What is an ideal diode? The diode having forward resistance 0 and reverse resistance infinite is called ideal diode. That is, we may consider that this diode is having no resistance. Now, the resultant voltage, here it is 3 and here is 1. Hence, the resultant voltage is 3 minus 1, 2 voltage applied to this diode. Here the resistance is 0, hence the only resistance in the circuit is 100 ohms. As you know, I equal to V by R. Here the effective voltage is 2 volt and the resistance is 100 ohms. That means 2 into 10 raised to minus 2 ampere. And here I may write it is equal to 20 into 10 raised to minus 3 ampere. 2 into 10 raised to minus 2 means 20 into 10 raised to minus 3. That means it is 20 milliampere. This is the current through this circuit. The current through the diode is 20 milliampere. Hence the correct answer is option B. Okay, as I told you, this is the most important chapter related to physics. A lot of devices are working based on the principle of electronics by reaching to IC and robots and satellites. Anything may be related to electronics. So work hard on this chapter. Try the most to win the best. Thank you for watching this video.